Yes, thank you very much, everyone. So today I'm going to present a little bit the results of my PhD thesis on the technology of medieval Venetian glass and the Levantine connections. So the emergence of Venice as one of the major glassmaking centers in the Mediterranean depended on many factors, and one of which was certainly the use of high-quality raw materials, which were very often imported from the Levant. The main source of information that we have on the type of raw materials and their provenance is the archives of Venice. However, these information are often sporadic, and we need evidence from the glass itself in order to evaluate their relative importance. So here I will present some LICPMS and isotopic data for glass from Venice, Padova, Asolo, and Cividale del Friuli, mainly dated between the 12th and the 15th century. I will also present some comparative data, in particular from the Levantine beakers, which are believed to be one of the earliest examples of enameled glass made in Venice, Mamluk glass, as well as other glass from the Eastern Mediterranean. So first of all, I would like to give you a little bit of background of what are the written evidence available and what type of information we have. So as I said, the main source of information that you have of the glassmaking industry in Venice is the archives of Venice. And the archives of Venice store the legislative and judicial documents which were generated over many centuries by the craft guilds as well as by the governing bodies responsible for controlling them. And the oldest indication of glass production that we have on the archives is an act of donation to the Benedictine monks of the church dedicated to San Giorgio in 982. And in this document, a certain Domenico Fiolario is named. And Domenico Fiolario is an early Venetian term to indicate a glassmaker, in this case, most probably a glass worker. And so this document is of exceptional interest for the story of the Venetian glassmaking, for the history of Venetian glassmaking in Venice, because it gives us proof of a glassworking activity as early as the 10th century, even though we do have archaeological evidence for a glassworking activity in the island of San Francesco del Deserto and San Leonardo in Fossamara as early as the 8th century. And by the 13th century, the Venetian glassmakers were already organized into a guild. And in Venice, guilds were institutions with economic power, religious and confraternal, which had confraternal functions, but they did not have political representations, like, for example, guilds of other Italian cities such as Florence. And the internal organization and legislation of the guild was controlled by the state through the issuance of several statutes, which were called capitolare or mariegola, and we have an example of one page of this capitolare or mariegola. And these statutes were controlling almost every aspect of the glass production. In fact, the first article of the Capitolare, I think that gives you an idea of how much it was important for the state to control the production, says that in order to practice their trade, the glassmakers had to take an oath of fidelity to the state. And in fact, the first article says che nessuno osi lavorare quest'arte per far vetro senza giuramento, which means that no one dares to practice the art of glassmaking without taking an oath. The state, well, first of all, it's important to mention that from 1292, the industry was officially relocated to the island of Murano, mainly for safety reasons, because of course glassmaking also poses the risk, for example, of fires, but also to have a better control on the production. And the state, in fact, was also controlling the procurement, the selection, as well as the export of the raw material used for glassmaking. And this is because the state recognized from the very beginning of this production the importance of using high-quality raw materials. And this was done to beat competition and ensure the predominance of the Venetian glassmaking production on the Italian, but also on the international market. In fact, in Venice, only one type of glass, flux, was permitted, and this was the plant ash from the Levant. And this because the other types of ashes were considered of inferior quality. The state was also particularly concerned about limiting the export of its precious raw materials to other glassmaking centers in Italy. And this because for preventing them to produce glass of a comparable qualities. We also have from the archives, we do have information on the types of raw materials used and the possible provenance. You don't really need to read this table, because don't even try. This is just an example of that I did for my thesis, of how many times the raw materials are named in the archives, the date of their mention, and the possible provenance. So one of the earliest documents that we have about technical information on the types of raw material used is this document dated to 1253, when vitrium is named among the goods imported from the Levant. And vitrium here refers to broken glass, so cullet, to be used in Venice as a raw material, so to be remelted and shaped into objects. So in this sense, this document does not prove the existence of a glassmaking activity in Venice, but only of a glass working. In order to have the first evidence of a glassmaking activity in Venice, we need to wait 1255, when we have a document which reports the import of alumen de Alexandria, which is namely a plantage for glassmaking from Alexandria in Egypt. And so this is the first evidence of glassmaking. However, the preferred types of flax for glassmaking by the Venetians was the plantage from Syria, and not from Egypt, which was considered of inferior quality. There are several documents which say that, they clearly say that the plantage from Syria was of better quality, while the plantage from Egypt was not only of a lower quality, but also had a darker color. We do have several documents referring to alume di Syria, which was the plantage from Syria. The first one is 1290, but we have several. In addition to the flax, of course, the other main ingredient to make glass, as we know, is silica, which in Venice was both in the form of sand or in the form of quartz pebbles, the so-called cogoli in Venice. Sand was used initially in Venice, but we don't really know from where it was coming from. So we do have several documents talking about the use of sand. However, the provenance is uncertain. We do know, however, that from the 14th century, sand was imported, for example, from Sicily, so it was used Italian sand. In later documents, reference to the use of sand appear less and less frequently, and this is because from 1332, the Venetian glassmakers started to adopt the use of quartz pebbles, as I said, the so-called cogoli, from the Ticino River, which is in the Milanese region, as well as from Verona. We also have later recipes, such as the Montpellier recipes, which report the use of sand from Jerusalem, as well as the use of Locan sand. And Jacobi, in one of his studies, also mentioned that sand from the Levant was imported to make glass, but we don't really know from which region. So now let's move on to the case studies of my PhD. So the samples analyzed come from four main case studies. The first one is the Basilica of Santa Maria Donato, which is located in Murano, where all the Venetian glassmaking was located from 1291. The basilica was probably founded in the 7th century, restored in the 9th century, and rebuilt in the first half of the 12th century. The glasses were found during consolidation works on the foundation and floors of the basilica, so unfortunately they do not come from an archaeological excavations, and they have been dated on the base of a typology by Gasparetto, which dated them between the 12th and the 15th century. Then we have the Baptistery of Padua, which is a religious building which is situated in Piazza del Duomo next to the cathedral, and a savage excavation carried out between 2011 and 2012 has revealed the presence of archaeological remains of different phases, and our samples are dated to the 14th and 15th century. The Rocca di Asolo is a fort on the summit of Monte Ricco in the town of Asolo, which was built in the 12th century, and during the century the fort had many owners, among them the bishopric of Treviso, the Carraresi family of Padua, but most importantly, during the 14th century, the fort was owned by the Republic of Venice. And archaeological excavation of the Monte Ricco site brought to light several phases, and abundant finds come from the high and late Middle Ages, and our samples are dated between the 12th and the 15th century. And then the last case study is the Palazzo dei Provveditori di Cividale, so the underground rooms of the present-day National Archaeological Museums of Cividale in Friuli, actually retained the remains of different phases of the building. And this was the original ancient patriarchal palace, which in the 16th century actually was demolished in order to build the new seat of the Palazzo dei Provveditori Veneti. So different phases were identified. The first phase date to the 7th, 8th century up to the Renaissance, and the objects found here are dated to the 14th and the 15th century. As we can see here, there are several different types of objects that I have analyzed. We have the typical Venetian inghistiere, which have the long neck. They should have a pot belly. And we do have different types of beakers. This is the so-called Cambassini beakers, and these are the typical Moioli beakers, which are flat base. Pranted beakers, which, as the name suggests, they are decorated with some prants, window glass, lamps, some other generic globular beakers, and ampoules next. So we do have a wide range of material. Comparative materials have been analyzed as well. As I said before, the Levantine glasses. We have mainly analyzed the base glass of the glasses, but also some blue enamel, because we were interested in the cobalt, as you may imagine. Then some Mamluk enamel glasses, glass from the Crusader site of Apollonia for comparison, and then I will also compare the data obtained with legacy data on Venetian and Eastern Mediterranean glass. And now let's move to the exciting part, not for everyone, but for me, of the presentation. So the results. So as we can see here, all samples are soda lime silica glass with potash and magnesia contents above 1.5%, which is indicative of the use of soda-rich allophytic plants as a glass flux. And this is fully consistent with our current understanding of the production of Mediterranean glass in the medieval period. However, when we look at those elements which are almost exclusively introduced with the silica source, we can divide the glasses into 6 main compositional groups, according to the different amount of alumina and titania, which can be considered to represent respectively the amounts of feldspar and heavy minerals present in the glassmaking silica source. As we can see here, group 2, which is the biggest group of sample, it is characterized by low silica-related impurities, relatively low contents of alumina, and as we can see here, group 2 presents the lowest amount of heavy mineral elements of all the other groups. Group 1, which is this, is characterized by relatively low levels of alumina comparable to group 2, moderate levels of titania, and it presents, which is quite distinctive, high contents of chromium combined with significant levels of zirconium. Group 3 has a very distinctive composition because it presents the lowest content of alumina of all the other samples, but it is somehow enriched in titania, as we can see here, and it presents high content of zirconium up to 250 ppm, while chromium is consistently below 18 ppm. Group 3 has been subdivided into 2 subgroups on the basis of the relative abundance of heavy mineral present, as well on the basis of the different typologies, because group 3A includes all the base glass of the Levantine beaker, so we can see a difference. Well, group 3 actually is characterized by the use of a silica source rich in feldspar, as it suggests the presence of high contents of alumina, while the heavy mineral contents are generally low and comparable to group 2, but it can be distinguished by group 2 by having a higher lanthanum over titanium ratio and a lower thorium over zirconium ratio. Group 5 is very similar to group 4, but it is somehow somewhat enriched in heavy mineral contents, and group 6 is only made of 3 samples, so it's not really a proper group, but we only have 3 samples which are characterized by high contents of sand-related impurities. So, while most of the groups identified also present very similar characteristics in terms of their plantage components, groups 4, 5, and 6 present lower content of magnesia, with group 6 also having lower contents of lime. And this might suggest the use of different types of plantage to manufacture these 3 groups, or maybe a different way of processing of the ash. As we can see here, we also have 3 samples from group 2, which present lower contents of lime and magnesia, but these are actually very probably made using purified ash, as also suggested by the later dating. So they're probably crystalloglass, so that's why they show these differences. This is to show that I also done some statistical analysis. Actually, I performed some PCA and hierarchical cluster analysis using log ratio transform data, which the analysis supports the existence of 6 main compositional groups. I had to plot PC2 and PC3 as well, because there was a lot of variance, and sometimes you couldn't see all of the groups in one plot only, but so the statistical analysis supports the division. We've also analyzed some of the blue decoration, for example, some of the blue rims of some of the bottles, as well as one blue enamel from the Levantine beakers. And the trace elements composition allow us to define some patterns. And we were able to identify the use of 2 main cobalt ore. The first one is associated with high zinc and indium, which is indicative of the use of a cobalt ore from Germany, which was in use between the 12th and the 15th century, so this also supports the dating of the samples. And the second cobalt ore is associated with high nickel, copper, and iron, and which is indicative of the use of another cobalt ore, always from Germany, but it was in use a little bit later, around the 15th century. And virtually all of the sample have been decolored using manganese oxide, the so-called glassmaking soap. So in order to understand a little bit more on the technology employed to make the glasses and the raw material used and their provenance, I have compared the groups obtained with the reference groups from the literature. And how we can see here, all of the samples appear to have been made with plant ash as a flux, which originates from the Eastern Mediterranean, and showing similarity mostly with Levantine and Syrian glass. Again, groups 4, 5, and 6 reveal some differences in terms of plant ash composition, and they are separated from most of the reference groups. So this might indicate, again, that maybe different types of Levantine ash have been used. The fact that this type of ash is not usually encountered in the Levantine example might suggest that maybe this type of ash was only used for the export. Of course, this is a pure speculation at this point. But what is interesting actually is that not even one sample appears to have been made using the so-called barilla ash. And barilla ash was a type of ash originating from the Western Mediterranean and not from the Eastern Mediterranean. For example, from Spain, Sicily, and Sardinia as well, and which was richer in potash than the Levantine ash. And this is important because this ash was widely used in other glassmaking centers in Italy, for example, in Liguria and in Tuscany. However, in Venice, according to the archives, this was prohibited, and only the Levantine ash was permitted. So far, our results seem to support the information found in the archives. Then the samples have also been compared in terms of their silica-related elements and with the reference group, but also with published data on Venetian glass. There are not many, but we do have some analysis of Venetian glass. So group 2, in terms of the major and minor elements, it resembles group of Venetian glass, so-called low alumina Venetian glass, dating between the 11th and 14th century, as well as a later group of Venetian glass called Vitrum Blancum. However, in terms of major and minor elements, this group is also very similar to glass from the Levant and Syria, and this has been very problematic so far because of this. They share a very similar technology, and that means that in terms of major and minor composition, they look very similar. However, as we can see here, this group is clearly different from the Levantine examples by having a distinctive trace element signature, in particular having a higher thorium over zirconium ratio, which clearly distinguishes this group from the Levantine example. So, given the similarities in terms of major and minor oxides with medieval glass from Venice and the distinctive trace element signature of this group, it is highly likely that group 2 was made, represent actually a medieval assemblage made in Venice, probably with a local or at least Italian source of silica, and most likely the famous Ticino cogoli or quartz pebbles from the Ticino. In contrast to group 2, group 4, as we have already seen before, is characterized by elevated levels of alumina, which are similar to that of the so-called high alumina Venetian glass dated between the 11th and 14th century, first identified by Verità and Zecchini in 2009. And these concentrations, such high concentration of alumina, are not usually encountered in contemporary glass from the Eastern Mediterranean, at least from that fluxed with plant ash. And also, this group is further distinguished by the Levantine glass by having a lower characteristic zirconium over hafnium ratio, which is similar to that of group 2 of Venetian provenance. So it is possible that the Venetians were using another source of silica, which was richer in alumina, but still presented low contents of iron, so it still produced a high quality glass. But most likely, this is actually my interpretation, is that those furnaces which were working outside of Murano, which were working according to the Venetian tradition, because these glasses typologically they look like Venetian glasses, they had a different supply of raw materials, as also suggested by the different composition of these groups in terms of the plant ash composition, because as we've seen before, this group also had a different plant ash characteristics. So group 1, it's a bit problematic because the group 1 has a chemical composition which is not encountered in published data of Venetian glass, and while high chromium usually is associated with Mesopotamian glass, I haven't found any compositional match with glass from Mesopotamia. And most likely, group 1, also because of the commercial routes between Venice and the Levant, is made with sand of raw glass, because we don't really know, imported from the Levant from a still unknown production site. And group 3 is our special group because, as I said before, this includes all the base glass of the Levantine beakers. When this group is compared with the Mamluk glass, it is different, not only in terms of the titanium of alumina ratio, which is what I'm showing here, but it may also differ in terms of other elements. And also the cobalt blue used to decorate the Levantine beakers is European because it's rich in indium and zinc. And this reconfirms a Venetian origin for the group. And the comparison with other Venetian, published Venetian glasses from the literature indicates that this composition is not usually encountered in Venice. However, a similar composition is found in Italy, in Italian glass dating between the 12th and the 14th century. For example, in the windows glass in Basilica di Santa Croce in Florence, dated to the 14th century, and also this group has a composition which matches that of a group called called Pranted Free, identified by Gliozzo and colleagues in 2021, which also presents a similar composition and high zirconium contents. So this was a type of silica source which was in use in Italy between the 12th and the 14th century, of still an unknown provenance. When this composition is compared with glass from the Levant, it shows some similarities with glass from the Levant, which was probably made using inland sand, and includes glass from Kirbat Alminia, Beirut, Apollonia, and Montfort. So it is possible that this silica source was imported from Palestine. However, we don't have a clear match yet, and we need further analysis to confirm that. Groups 5 and 6 are two small groups which show high silica-related impurities, and also they present different plant ashes. Such an impure source of sand do not match any example of the Venetian or Eastern Mediterranean glass, so these probably represent a minor production types made with a very low quality raw materials which were not available or were not permitted in Venice. So these groups were probably made somewhere else in the northern Adriatic. And when we look at the typology of these two groups, maybe we are also able to say a little bit more about the possible provenance of these groups. And this because this type of low quality glass was used exclusively for the production of bottles. For the majority of the crop flasche type, which are these ones. So the recurrence of this type of bottles in several excavations in the northeast of Italy suggests a North Adriatic origin for this form, or at least for the Italian variant of these forms. And furthermore, it has been suggested that might have been used as ink container. So if their ink containers function is assumed, it is possible that containers have traveled together with their contents. So meaning that this type of glass was maybe frequently traded to one center to another. So yes, again, these were probably non-Venetian types. Again, we do have another type. When I showed this to a colleague in Venice, he told me that this is a bottle that who doesn't know how to make glass can make, so it's probably very bad quality and was probably made somewhere else in the Northern Adriatic. So we did some isotopic analysis, and the strontium and neodymium isotopic analysis of the glass allows some patterns to be identified, which can also provide some further insights about the provenance of the material used. So as we can see here, groups 2, 1, and 3 all have the typical strontium isotopic signature of Syrian plantage glasses, which is considered at least to reflect the use of inland source of plantage from Syria. And this result supports the interpretation of the major and minor trace elements compositional analysis of the glass samples and provide the first secure scientific evidence for the import of Syrian plantage to Venice, again being in agreement with the archives. Groups 4, 5, and 6, however, present a higher strontium signature, and which are similar to that of the Sercirimani glasses, and also to that of the Levantine beach sand. And recently, Henderson has suggested that a higher strontium isotopic signature might reflect the use of plantage originating from a maritime environment near the Levantine beaches. So it is possible that these groups actually had been manufactured using a different source of supply of the plantage, not from the inland, but from the coast. The groups identified also show differences in terms of a neodymium signature, which the neodymium signature gives us information about the source of the silica sand and not about the plantage. Importantly, group 2 present a neodymium isotopic composition, which is in agreement with its inferred Northern Adriatic provenance, and this is because the analysis of beach sand from the area have demonstrated that these have similar neodymium values. And also, analysis of the Venetian Cristallo and Vitrum Blancum glass present neodymium signature which fall in the same range. Group 1 has a neodymium signature which is comparable to that of glass from Banias, Tyre, and the Sercirimani, confirming that this group of glasses was indeed made using sand imported from the Levant. Group 4, 5, and 6 present a even higher neodymium signature. And while such young neodymium signatures might indicate the use of sand from the Levant, the major, minor, and trace elemental composition that we've seen before exclude this possibility. So, similar neodymium signatures have been found in North Italy, specifically in Liguria, in the Liguria region, due to the presence of ultramafic rocks in the area. So, it's possible that these samples with these groups have actually been made in that region. And also, there are also ultramafic rocks in the volcanic province in Venice, in the Venetian volcanic province. So it's possible that these glasses have been made somewhere else, not in Venice Island, but in the mainland. Group 3 has a neodymium signature which is similar to that of Arraca. However, as we can see here, we also have performed some hafnium isotopic signature, and this group is characterized by very, very low hafnium isotopic composition. And this is interesting because a recent study by Morag and colleagues in 2021 has suggested that siliclastic sediments from inland Israel, some from continental basins in inland Israel, do have a very low hafnium signature. So it is possible, but as we suggested before, that maybe they were importing sand from Palestine. However, we should know we don't have hafnium isotopic analysis for Syrian glass, so this is very important. So where do we go from here? So we talked a little bit about the provenance of the raw materials. We have seen when in Venice they were importing a lot of raw materials from the plantage to the sand, but we were also using local sand. So the situation was complex. What we can see, however, that most of the samples, despite the use of different types of sand, they do share quite similar characteristics in terms of the chemical composition, in terms of the major and minor elements. In fact, most of the samples are made with Syrian inland plantage. They present low contents of alumina, low levels of iron, and this suggests that the Venetian glassmakers were working towards a standardized composition. So the main product made in Venice was high quality glass. And it was a standardized production. And standardization can be explained, as we know, by several factors. Can be maybe the results of more routinized production processes, of increased industrialization, or even it can reflect the skills of the glassmakers, because they were so skilled they were able to be very consistent in their production. However, in the specific case of Venice, I think that these reflect the results of the government regulations. In fact, this was done to control the prices, to enforce the quality standards, and as argued above, this clear glass, this high quality glass, was also destined for large scale and international trade. So it had to compete with the product not only of other Italian glassmaking centers, but also internationally. So therefore, the materials used to make this type of glass were procured from selected sources and were prepared in standardized ways in order to ensure the high quality of the final products. And this clear glass became the signature of the Venetian glass production. As we know, this led to the production of the famous crystal glass in the 15th century, which was so clear to resemble rock crystal, and that led to also and stimulated the production of other glassmaking centers in Europe, because they were trying to imitate the Venetian glass production. Just to conclude very briefly, we have identified 6 main compositional groups linked to different raw materials. The plantage was imported from the Levant, so it is true, they did that. The largest group of glasses, it has a distinctive trace elements composition, and this is important because we can distinguish it finally from Islamic glass, because we couldn't, and now in theory we can. And then we also find other groups of glasses rich in alumina, which were likely Italian but made not in Venice itself. Sand was also imported from the Levant, and importantly, the Levantine glasses, they differ from the Mamluk enameled glasses, and this reconfirms a Venetian origin for the group, and the similarity with glass from Crusader sites might suggest a possible technological transfer, but it is not conclusive yet, and I hopefully will be my next research topic if I will be funded. Thank you.